Hello, my name is Sungjundo. Then let's start. What I'm going to talk about is gripper for drone delivery. This is summary of my presentation. My topic is drone gripper. Many people having a hard time recently because of COVID-19, but the delivery industry is not. Drone delivery has become more popular by COVID-19. The gripper usually look like that. The load is fully transferred to the motor, so I made a new drone gripper. To make the body of gripper, the goal is to minimize load to servo motor. Then this is the model I made in Inventor. The delivery box is on that small ball with wire. Like the picture on the right, most loads are sustained by gripper body, not by the servo motor. The actual picture is as follows. Now I'm gonna talk about the circuit. It is top view and I use IMU sensor, variable register, LED, and servo motor. This is picture of a whole model that combines body and circuit. In the back, I made a door so that the circuit could be fixed at any time. Now let's move on to code. Code can be divided into three parts, like this. And this is core technology of Gripper. This is first part. I divided the delivery situation into four. Variable resistance was used to represent each mode. Explanations through code are just boring, I know. So I prepared something cute. For an easy explanation, that is mini drone. I made it. I made it one by one. And mode 1, hanging a delivery box. Mode 2, moving like this. Mode 3, dropping box. Mode 4, emergency. The servo motor was properly controlled for each mode. It adjusted the angle of the servo motor. Instead of a detailed explanation, I prepared videos. This is about a serial monitor. It received acceleration through IM sensor XYZ and calculate the stability with proper equation. Also, I print out the mode. And using variable register, I can choose the mode and servo motor works properly. This is for mode 1 to 3. 1, 2, 1, 2, 3. Servo motor works properly. Next is load the cement. This is mode 1. As the propeller opens, the shipment can be loaded. And this is mode 2. The propeller closes again. It grabs the box tightly during delivery. Next is dropping box. If I give a signal to drop, gripper determines stability on its own, and if the condition is met, drop it. signal and drop it. Next is for emergency. I assumed an emergency like box stuck in a tree. It separates box and drone and deliver location information to the computer so that the box can be retrieved later. Drop the box and LED is on and off and it deliver emergent information of information of location. It deliver information of location. And it is key point. So my mini drone helps you to understand. When it got the signal to drop, but if the shaking is severe, it does not drop. However, if shaking stops and stays stable for 3 seconds, it drops. I made this system using IMU sensor and filter. IMU obtain acceleration values for each axis using the IMU sensor. However, noise can cause the value to fluctuate. So, filters should be used because this plays a very large role in determining stability. I use I used moving average filter. To print simply, it prints out an average value. When one value is splashy, the average value does not fluctuate significantly. Like this, it throws away the oldest value and get a new one. And it's like moving right. So this name is moving average filter. This is actual result of using it in Arduino. Overall, overall the value was stabilized, especially when looking at the circle, the effect could be greater as the value bounced like this. Using these filtered values determine stability, and if it's bad, it wait, and if good, it drops. This is for video. It never drop when it's in not stable state, but if it's in stable state for 3 seconds, it drops. Stable 1, 2, 3, and drop. This is loading test. You can hold the box title. Is actual flight test. I remove unnecessary point. It is simple version of my creeper. And then it also use just checking system for stability. Checking and drop. Thank you for watching my presentation. And if you want to know details of my project, everything is in the report. Thank you.